K-means clustering is a machine learning method that attempts to take multiple different data points that you might not know anything about and apply some structure to them that you can understand. It attempts to take those data points and group them into a set number of clusters defined by the variable k. Now this can be very useful in multidimensional analysis when you have lots of interactions between variables and you want to understand how those interactions are driven. To visualize the concepts of k-means clustering, Stanford University provides this visual simulation. Here, each of the black points represents a different data point in my data set, and I have a k equals to 3, which gives me 3 centroids indicated by these 3 different colored triangles. These are randomly placed across my data set. Now to minimize the distance, I first need to calculate the distance from each point to a centroid. So when I hit the blue button, you'll see each point change to a different color, and that corresponds to the nearest triangle and the nearest centroid. And the distance between all of these is shown below the visualization. Now this is going to iteratively calculate, so as I continue to hit the blue button, you'll see a new calculation as those centroids move closer to the clusters of data points. And as I continue to iterate on this, the clusters will become more clearly defined until eventually that distance calculation converges and my clusters have been defined. So let's take a look at this in Spotfire. In Spotfire, I'm going to use my familiar World Bank data set that has different countries around the world and attributes of the populations in those countries. Now, I've already used my data relationships tool to find numerical relationships between the water source and the percent of population that has access for a country, and then all the most highly related variables. And each of these points represents a different country, and you can see that by me selecting those labels popping up. So to do k-means clustering, I'm going to create a line chart. Now k-means clustering must be driven from a line chart, so you must do this step first. Now I'm going to select some columns for my multivariate analysis, and I'm going to select the top few variables here, and I'm going to include the water source with percent of population that has access. After I've selected the variables I'd like to analyze across, I'll hit OK, and whenever I'm using a line chart with multiple columns in the y-axis, I need to go ahead and make the x-axis column names. So I'll do that, and I need to line this by country. So now each individual line represents a single country across these 5 variables. So to do k-means clustering, I can either go to Tools and k-means clustering, or I can just right-click directly on a chart and do k-means clustering from here. And this is going to create a new column named k-means clustering. I can change the name if I'd like, and I can choose how many clusters I want, and I can choose the distance measure. So which distance measure should I use? Much like the line similarity methods, there's 2 methods for k-means clustering. There's a Euclidean distance method, which looks across the different variables on the x-axis and seeks to minimize the distance between the points on the y-axis. Now this is what was shown with that Stanford example in the beginning, however that was shown in a 2-dimensional plane. Now, there's also a correlation similarity method, and this is looking at the shape of the line instead, and it's going to try to find other lines that have the same shape, even if they're much higher or much lower than the position of your original line. It's just going to look to find the other shapes that are the same, the other profiles that are the same. So back in Spotfire, I'm going to choose the Euclidean distance method, and I'm going to select 5 clusters. And I'll hit OK. Now that has calculated a new k-means column for me. Let's visualize this a little bit with a map chart. And here I'm going to take my new k-means column. Let me search for that. Got a k-means clustering column. I'm going to color each of my charts by this so we can see this a little bit better. And one more chart here. And now you can see these countries have been clustered into these 5 clusters. And there are empty values for when I had missing values on some of these variables, they couldn't be clustered. So Spotfire's put this into an empty trellis. Now you can see already that these clusters have identified some of the industrialized countries here in green, the industrializing countries in yellow, and some of them in red, and then the least industrialized countries in blue. And that's just looking at some of these variables. It's already found these clusters. I haven't even told it which are the industrializing or industrialized countries. Now over on my data relationship scatter plot, you can see a cluster of green, yellow, red, and blue points. These are all using, again, the Euclidean distance method, and it's showing how those clusters are all close together across these 2 variables. Now, when I select a different 2 variables, They're still grouped together because, again, I used the most highly related data, and a lot of the variance is explained by these clusters. So I can continue to go down, and you'll see the variance is all explained by these clusters. They're all grouped together. But when I get towards the bottom, then you'll see they start to mix up a little bit more, and it's harder to pick out where the clusters are because there's more variance across those variables. So that's how you use k-means clustering in Spotfire. Again, it's very useful for multivariate analysis when you're trying to add some structure to your data and understand how it's all related to each other.